The moon has fascinated humanity for millennia, casting its silvery glow across our skies and stirring our imaginations. From ancient times, people have looked up in wonder, weaving stories and legends about this mysterious companion in the night. Its phases have marked the passage of time, guided calendars, and inspired countless works of art, poetry, and music. Inspiring myths and dreams of exploration, the moon has been a symbol of the unknown, a distant world just out of reach, beckoning us to discover its secrets. Civilizations across the globe have charted its movements, built monuments in its honor, and even imagined gods and goddesses living on its surface. Once a distant, mystical object, science has revealed it as a world with its own history and secrets. Through telescopes and spacecraft, we've uncovered a landscape shaped by ancient impacts, volcanic eruptions, and billions of years of cosmic evolution. Each new discovery has peeled back another layer of mystery, showing us that the moon is far more than just a barren rock in the sky. The Apollo missions gave us our first real glimpse, showing the moon as a dynamic, complex place, not just a dead rock. Astronauts brought back samples, photographs, and stories that changed our understanding forever. We saw Earth rise from the lunar surface, a breathtaking reminder of our place in the universe. Yet the true nature of its interior, its core and mantle, remained elusive, waiting for new technology to probe deeper. The instruments left behind by Apollo could only scratch the surface, leaving many questions unanswered about what lies beneath the moon's crust. Why do we care about the moon's core? Because understanding its inner structure could unlock the story of how the moon evolved and, by extension, how our own planet came to be. The moon's core holds the key to its magnetic history, its volcanic past, and even the forces that shaped its surface, because it's the key to understanding how the moon, and even Earth, formed. By comparing the moon's interior to Earth's, scientists can piece together the violent events that shaped our solar system, and perhaps even learn how other planets and moons formed elsewhere in the cosmos. The leading theory says the moon was born from a colossal impact with early Earth, so its core could hold clues to our own planet's origins. If we can decode the moon's internal structure, we might finally understand the aftermath of that ancient collision, and how it set the stage for life on Earth. Today, with advanced technology, we're finally able to listen to the moon's interior with unprecedented clarity. Sensitive seismic instruments can detect moonquakes and vibrations deep below the surface, revealing details about the core's size, composition, and activity that were once impossible to measure. A recent seismic signal suggests the moon's core is far more active and complex than we ever imagined. These findings challenge old assumptions and open up new questions about the moon's evolution, its magnetic field, and the processes still shaping it today. This discovery marks the dawn of a new era in lunar science, promising answers and more mysteries about our closest celestial neighbor. As we prepare for future missions and continue to explore, the moon remains a world of wonder, inviting us to keep searching, keep questioning, and keep reaching for the stars. To uncover the moon's secrets, we listen to its quakes, moonquakes, using seismology. Unlike Earth, the moon's quakes come from tidal forces, meteor impacts, and mysterious shallow tremors. Apollo's seismometers gave us a first look, but their data was limited. Now, a new network of ultra-sensitive sensors from the Artemis program is mapping the moon's interior in detail. Seismic waves, P waves and S waves, reveal what's inside. P waves travel through everything, S waves only through solids. If S waves vanish, it means there's something molten inside. The latest deep tremor sent waves through the entire moon, and the absence of S waves in key areas points to a partially molten dynamic core. This challenges decades of assumptions and opens a new chapter in lunar science. For the first time, we're getting a high-resolution scan of the moon's heart. The data is rewriting what we thought we knew about our nearest neighbor. Major space discoveries rarely come with fireworks. They don't announce themselves with grand spectacles or dramatic scenes. Instead, they're found in data, not spectacle. The real excitement lies in the numbers, the graphs, and the subtle signals that scientists decode. Dr. Michio Kaku reminds us, the real breakthroughs are in the squiggly lines, not Hollywood explosions. These lines tell stories of cosmic events and planetary secrets. The new lunar core signal isn't a disaster movie moment, it's a scientific revolution. It's a quiet revelation that could change our understanding of the moon. The drama is in the data, forcing us to rethink how planets form and evolve. Each piece of data adds a new layer to the story of our solar system. Kaku also warns that outdated space laws can't keep up with today's crowded, competitive space environment. The rapid pace of discovery and exploration demands new regulations. A dynamic lunar core could mean new resources and new risks, raising the stakes in the modern space race. It's not just about exploration, it's about survival and progress. For space to benefit everyone, we need updated international rules, not just for science but for peace and cooperation. The future of space exploration depends on global collaboration. The moon's seismic whispers are a wake-up call. The future of space is being written now, in data and diplomacy. Every discovery is a step towards a new era. The discoveries challenge our models and our politics. They push us to think beyond our current understanding and to prepare for new realities. The real story is just beginning. As we uncover more, we realize how much there is still to learn. The journey of discovery is endless. The new seismic data upends our old model of the moon's interior. For decades, scientists believed the moon was a geologically dead world, with a small, solid core and little internal activity. But these fresh findings are rewriting that story in dramatic ways. Instead of a small, solid core, we now see compelling evidence for a much larger, partially molten one, something that was once thought impossible for our lunar neighbor. This means the moon's heart is far more complex and active than we ever imagined. This molten core could generate heat and even a weak magnetic field, making the moon more geologically active than we thought. It suggests that the moon may have once had a much stronger magnetic field, and that some of that energy could still be lingering deep inside. It raises big questions. How has the moon stayed hot for so long? What processes are keeping its core partially molten after billions of years? Could there be unknown sources of heat, or is the moon's interior cooling much more slowly than we thought? What does this mean for its formation? If the moon's core is so different from what we expected, it could mean our theories about how the moon formed, perhaps from a giant impact with Earth, need to be revisited or refined. If the core is less dense and more dynamic, it could change our theories about how the moon, and even Earth, came to be. The relationship between our planet and its satellite might be more intertwined than we realized, with shared histories written deep within their cores. This also affects practical plans. A restless core could impact where we build lunar bases and how we search for resources. Understanding the moon's interior is crucial for future missions, as it could influence everything from mining operations to the safety of astronauts. The discovery forces us to rethink everything from the moon's birth to its future as a destination for exploration. Every new piece of data reshapes our vision of what's possible on the lunar surface and beneath it. The moon is no longer just a dead rock, it's a world with a hidden dynamic heart. Its story is still unfolding and we're only beginning to understand its mysteries. Each new answer brings even deeper questions, reminding us that the moon is not just a relic of the past, but a living laboratory for discovery. As we probe the moon's core, another race is on. For water. On the moon, water is more valuable than gold, essential for life and rocket fuel. The discovery of ice in shadowed craters could make a permanent lunar presence possible. Water can be split into oxygen and hydrogen, supporting habitats and fueling missions deeper into space. A moon base with water access becomes a launch pad for the solar system. The search for water is driving the new space race, with nations and companies vying for control. A dynamic core could mean more internal heat, possibly moving water toward the surface over time. Understanding the moon's interior could point us to the richest ice deposits. The quest for water and the quest to understand the core are deeply connected. Both are reshaping our plans for humanity's future beyond Earth. Why are we making these discoveries now? One word: technology. Today's computers and sensors are light years ahead of Apollo's era. Your smartphone outpowers the computers that sent astronauts to the moon. Modern seismometers and orbital probes can detect faint signals and map the moon in stunning detail. Advanced algorithms sift through torrents of data, revealing patterns that were invisible before. The Artemis program's sensor network gives us a 3D view of the moon's interior. Ground-penetrating radar and spectrometers map the surface and subsurface from orbit. This synergy of sensors and computing power is revolutionizing lunar science. We're not just listening to the moon, we're giving it a full-body scan. The results are transforming our understanding of our closest neighbor. The moon's new secrets come at a time of rising competition in space. The old US-Soviet rivalry has given way to a crowded field: China, India, private companies, and more. The discovery of water and a dynamic core raises the stakes. Control of resources could mean power in space. The legal framework, built in 1967, is outdated and vague about resource rights. Some argue you can't own the moon, but you can own what you extract, a recipe for conflict. Without clear rules, a lunar gold rush could spark disputes far from Earth. Experts like Dr. Kaku warn that science is racing ahead of law and diplomacy. The moon's dynamic core adds urgency, new resources, new risks, and new reasons for nations to compete. We need international agreements before the first permanent base is built. The challenge is to keep pace with science and avoid repeating Earth's mistakes. The Outer Space Treaty was groundbreaking in 1967, but it's no match for today's realities. Multiple nations and private companies are ready to build, mine, and settle on the moon. The treaty's noble ideals lack the specifics needed for a crowded commercial lunar future. We need new rules. How do we allocate landing sites? Who gets to mine water? How do we protect historic sites? The Artemis Accords are a start, but they're not universal. Major players like China and Russia aren't on board. Without a global agreement, we risk a fractured, lawless lunar landscape. The discovery of a dynamic core makes this urgent. We're managing a living world, not a dead rock. Our laws must evolve as fast as our science. The moon's dynamic core is a scientific milestone, and a crossroads for humanity. We face a choice: compete for control, or cooperate for discovery and peace. No single nation can tackle the challenges of lunar exploration alone. An international lunar base could be a hub for science, resources, and missions deeper into space. The International Space Station proves that global cooperation works, even in orbit. We must apply those lessons to the moon, building a framework for shared exploration. The Artemis Accords can be a starting point, but we need a truly global conversation. The moon's seismic signals are a call to action. Return not as conquerors, but as partners. By choosing cooperation, we set a precedent for peaceful expansion into the solar system. Our future in space depends on the choices we make now, together.